switch in the middle. There can be no other equipment connected in the middle. I don't need to request your MAC. I don't need to do ARP. I will not send ARP packets. Packets will not be dropped. Because I sent it to you. I will reply immediately. Will not request timeout. Next we are going to start configuring EIGRP. Very simple. Let's first look at R1. If we want to configure, definitely need to enter configuration mode. After entering configuration mode, we're typing router IGRP here. Then enter a question mark. Here you can see an as autonomous system. This is called as number. That is in EIGRP. Here is also to specify the AS number. But here it is written EIGRP 100. All four devices are consistent. We put 100 here. This is equivalent to. You give the autonomous system of EIGRP a name. But if we now configure, must be within an autonomous system. We now configure it with 100. Specify an AS number. The following word. EIGRP not only supports AS number. It also supports naming. This thing will be more complicated. When you arrive at IE, you will speak. Then when we enter the routing view of EIGRP, must first enter a command. Please pay attention. We must first turn off auto summarization. No auto summary. This command is very important. If you don't enter this command, then this will be enabled by default. There are many commands enabled by default in Cisco. You must remember each. No auto summary is to turn off automatic summary. This automatic summary is what I just told you. 172.16.1.0 bar 24. This is a class B address. If you don't turn off automatic summarization, it will spread to you. 172.16.0.0 bar 16. For example, I am on the device R1. A network segment of 172.16.1.0 bar 24 is connected. If this network segment is declared in this EIGRP, but the automatic summary is not turned off, here at R4, what it learns is 172.16.0.0 bar 16. I learned it wrong. So this command must be entered. After turning off automatic summarization. It's a normal announcement. For EIGRP, it declares in 2 steps. The first step is to establish a neighbor relationship. That is, R1 and R2 are directly connected. They both run EIGRP. Declare the directly connected network segment. R1 declared. R2 also declares. Since the interface of R1 and the interface of R2 are in this segment, so just declare this network segment. This interface will be declared in. EIGRP starts to send hello packets out. The left interface of R2 is the same. So if we are using EIGRP to declare, first declare your direct connection. As long as the device wants to establish a neighbor relationship with the peer, the two ends must declare direct connection to each other. This is the first step. The second step is to pass the route. The reason for establishing a neighbor relationship between devices. It is because there is a network segment that wants to be passed to the other party. I will give you a simple explanation. If we don't use dynamic routing, we use static routing. You need to manually enter. Now as long as the dynamic routing protocol is running, we only need to establish a neighbor relationship with each other. I declare a 1.0 network segment on R1. All devices can learn. This is the difference between dynamic and static. If this 1.0 network segment is gone, R1 will send link status updates to other devices. All devices will delete this network segment. This is the purpose of the declaration. Then we start declaring. The declaration is called network. We enter a 12.1.1.0 here. Then here. Let's make a positive announcement first. For example, 255.255.255.0. After the announcement, let's check. Do show run. Check router EIGRP. Is this command? Look. See what I have configured for my EIGRP. I am on this device. First up an EIGRP 100. And I declared a network segment of 12.1.1.0. Everyone can see. Write 0.0.255 behind. But the network I just entered. It seems to be 12.1.1.0. 255.255.255.0. Why did it become like this? Isn't this a bit strange? Well, first of all you need to know. This thing is called a mask. This thing is called a wildcard. Wildcard mask. The mask we're talking about is the subnet mask. Mask is the kind of continuous 1 and 0. And 1 in the front and 0 in the back. 1 means an exact match. Is the network bit. 0 means no matching. Stands for random. Is the host bit. So before talking about wildcards, let's look here first. 3255 and 10 represent 24180. 30 and 1255 represent 24 and 81. Actually, you can temporarily understand it as an anti-mask. In the NA stage, just understand it as an anti-mask. Anti-mask is consecutive 0 and 1. And 0 is in the front and 1 is in the back. 0 and 1 cannot be interspersed. 0 means an exact match. 1 means no match. That is random. This is called anti-masking. It's the exact opposite of what we call a mask. So what are wildcards? The NP stage of this thing will focus on it. Wildcards can be shuffled. It is a mask that can jump. Wildcard mask can be a combination of scrambled zeros and 1s. Then 0 means an exact match. 1 represents random. Here is actually a wildcard. But at this stage, you can understand it as an anti-mask. Here are some differences between them. So for us, actually, we need to declare its mask via wildcard. But if you declare a positive mask, it will automatically give you the input in the form of wildcards. You will do data capture in the future. When including some strategies, use it often. ACLs including the NA phase also use wildcards. But also consecutive zeros and 1s. For R1, I just made an announcement. Then I will redeclare here. For example, network 12.1.1.0. 0.0.0.255. Let's change it. It doesn't matter whether you change it or not. But it's better to change it. We want a correct declaration. Then we also declare. Establish a neighbor relationship with R3. Then declare 13.1.1.0. 0.0.0.255. So for now, we're actually done. R1 is now declared. Direct connection with R2. And the internet segment of R3 have been declared. Then it is time to declare the network segment behind. But R1 has no network segment. Because there is only one network segment